Hey everyone! Today I want to talk about something that's truly essential for any data scientist out there: K-fold cross-validation. If you've ever tried to evaluate a machine learning model's performance, you know how critical it is to ensure that your model isn't overfitting to a particular train test split. So, what exactly is cross-validation? Simply put, it's a resampling technique used to evaluate a model's performance and generalization on unseen data. By dividing your dataset into multiple parts, or folds, you can train your model on some parts and validate it on the remaining parts. This process is repeated multiple times, and the average performance across all runs is considered the model's final score. But let's zoom in on one of the most popular methods: K-fold cross-validation. Here's how it works. You split your dataset into K equally sized folds. For each run, you train the model on K1 folds and validate it on the remaining fold. This process is repeated K times, each time with a different fold used as the validation set. Finally, you average the scores from all K runs to get the model's overall performance. Let's break it down with an example. Suppose you have a dataset of 1,000 records, and you choose K equals sign 5. You'd split your dataset into 5 folds of 200 records each. For each fold, you train on 800 records and validate on 200 records. This is repeated 5 times, with each set of 200 records taking a turn as the validation set. After all 5 runs, you aggregate the validation results, whether it's accuracy, RMSE, or another metric, to evaluate your model's performance. Why go through all this trouble? Well, K-fold cross-validation offers some pretty significant advantages. First, it provides a more reliable estimate of model performance than a single train test split. Second, it utilizes the full dataset for both training and testing, making sure no data goes to waste. And third, it reduces the risk of variance due to random splitting. However, it's not all sunshine and rainbows. One downside is that K-fold cross-validation can be computationally expensive, especially for large datasets and complex models. Additionally, it may have higher variance if your dataset has imbalanced classes or time dependency. In those cases, consider using stratified or time series cross-validation instead. And that's a wrap. I hope this gave you a clear understanding of K-fold cross-validation and its importance in model evaluation. If you found this video helpful, don't forget to like, share, and subscribe for more data science insights. See you next time.